Good day, everyone. Our project is titled Gas Processing Plant Operational Analysis, conducted under the course Operations and Control. This study examined the operational performance and planning issues of a gas processing plant located in Malaysia. The purpose of this presentation is to analyze how operations management tools can be applied to improve efficiency, cost control, and decision making. Today's presentation covers the orientation, background, problem statement, and objectives, capital management, forecasting analysis, SWOT analysis, and the key conclusion delivery from the study. Here are the presentation outlines. First one, introduction. This study focuses on operations planning and control in a gas processing plant. In continuous process industries such as oil and gas, operational decisions are closely linked to capital analysis, production accessibility, and cost efficiency. Because gas processing plants operate with high fixed costs and limited flexibility, effective planning and control are required to reduce loss and improve performance. Therefore, applying system operations management analysis is essential for supporting informed and data-driven decision-making. For this one is orientation background. Gas processing plants are critical components of the oil and gas supply chain. Their main function is to convert raw natural gas to marketable products such as natural gas, LPG, and condensate. These plants operate continuously and require suitable coordination between customer demand and cost. Due to high fixed operating costs, even a small gap between effective calculated and actual output may result in significant financial losses. In addition, market demand fluctuations, environmental regulations, and energy translation pressure further increase operational challenges. And this is for our problem statement. Based on operation data, for key changes are indefined. First, a capital gap exists between actual output and effective capability, indicating unrealized production potential. Second, demand fluctuates between 108 and 115 per month, calculating production planning. Third, high fixed cost per month is required careful break-even control. Finally, environmental regulations, computation, and market volatility created eternal operational pressure. For this one is our problem objective. For this one, the objective is this study are via follows. First, to evaluate operational performance, sound capability analysis. Second, determine minimum valuable output using break-even analysis. Third, to compare demand forecasting method using standard inner measures. Finally, to assess structured positions through SWOT analysis. In one word, the overall aim is to develop practical recommendations for operational improvement. For this one is our problem scope. This study focuses on a gas processing plant located in Karit, Tenggaru. The analysis is limited capital management, break-even analysis, demand forecasting, and structure evaluation. Forecasting is based on monthly sales data from 2020 to 2021. Technical process design, redesigned, and detailed supply chain optimization are excluded. Several assessment points are made to ensure consistent analysis. Operating conditions are understood to remain stable. Historical data is assumed to represent demand and trends. Price and variable costs are assumed constant. For methodology, the methodology includes the capital management analysis, break-even analysis, demand forecasting, and SWOT analysis. All data were validated before analysis.
Hello everybody. Now I will complete the methodology section. For data collection process, it's obtained from some steps: operational data collection, monthly production output, design and effective capacity data, working hours, operating day, and workforce information. For financial data collection, fixed cost including utilities, electricity, and equipment leasing, variable cost per unit for natural gas and condensate, selling price, and annual forecasted sales volume. For sales and demand data, historical monthly sales data from January 2021 to August 2021, data prepared in time series format for forecasting analysis. Strategy and extreme data, internal operational insights from plant management, external information from industry reports and government publications, data validation and preparation, cross-checking data for competency and consistency, removal of missing or abnormal value before analysis. For the analysis technique, in this work we will upload and we will work on the in these strategies and method, starting with capacity management analysis. Utilization rate calculate using actual output and design capacity. Efficiency measured based on actual output relative to effective capacity. Used to identify operational performance gaps and system bottlenecks. For the second technique, break-even analysis, contribution margin approach applied for each product, natural gas, LPG, and condensate. Weight average contribution margin are used due to multiple product mix, determine minimum production and sales level required to cover fixed cost. For the third technique, demand forecasting technique, time series forecasting based on historical monthly sales data, and methods apply moving average, weighted moving average, and exponential smoothing. Forecasting accuracy evaluated using MBA and MED and MCE. For SWOT analysis techniques, identify strength, weakness, opportunities, and threats used to support strategies and operational decision making. For the data collection information, for forecasting data information, as shown here in the table of monthly gas processing volume for gas processing plant, and the total for the sales is 2,166. For the capacity management data, the design capacity is around 160 mmcsv month, which is maximum gas processing capacity under idle conditions. Effective capacity 145, capacity adjusted for maintenance and operational losses. Actual throughput 132 monthly, average processed gas volume, and working day 13 days month in the month. Continuous plant operation, operating hours 24 hours daily, continuous operating in three shifts. Workforce 85 employees total, operational and technical staff. For the forecasting techniques and work will be applied in this section. The first technique in forecasting method is a moving average method. Here the calculation that use to apply this method and the equations here. The actual forecasting the actual to forecast was 177.225 for the sum, and for x forecasting error was 3090.5, and for absolute percentage error was 133.35. And the moving average was 123.25 results, and for actual to forecasting result was 16.75. For forecasting error was 218.56, and for absolute percentage error was 11.96 percentage. For the second technique in forecasting, which is weighted moving average, and we use 4 months for moving average, and here's the table that contain the calculation results for 4 month weighted and for actual forecasting sum is 166.8, and for forecasting error is 2737.4, and for absolute percent error is 125.16. For the 4 month weighted average calculation was 124.1, and for actual forecasting was 15.9, and for forecasting error actual for forecasting error is 252.81, and for absolute percentage error was 11.36. For the last technique in forecasting that we did it in this work, which is exponential smoothing method, and here's the calculations result by and this table are showing the result for actual forecasting 230.91, for forecasting error 3532.64, and for absolute percentage error was 171.46. For exponential symbol calculation with alpha 0.1, data for February 2021 is taken. A new forecasting cell forecasting for the new forecasting cell is 120 in February, and for actual forecasting is 8, for forecasting error is 64, and for absolute percentage error result was 6.25%. Here's the graphically results for these three methods. For forecasting, for forecasted 2021 sales using moving average method, as you can see here, the blue line for actual sales between 120 to 104, and for monthly average, which is the red line, between 120 to 140. For the forecasted in 2021 sales using weighted moving average method, also showing the distribution between 120 to 160 between the blue and red line. For the forecasted using exponential method, also the distribution showed the result between 100 to 160 between actual and forecasted sales. And to calculate the common measures error and to calculate the common measures error for these three methods, we applied these equations to find the mean absolute percentage error. For moving average method, it was 11%. For month weighted moving average was 9.51 method, and for exponential smoothing method was 10.71%. And for mean square error result, for moving average method was 8.45 million ringgit. For weighted moving average, mean square was 10.42 ringgit million. For exponential smoothing method was 14.3. The mean square here was 14.3 million ringgit. For the mean absolute deviation for moving average method was 147.13, and for weighted moving average was 132.04. For exponential smoothing method was 168.22.
Moving on, we will be discussing about the SWOT analysis that have been conducted in order to understand the internal and external factors that is affecting the plant. For the strength, the primary strength of the plant lies on the strategic location, especially within Malaysia's petroleum and gas hub, which is in Kerteh, Terengganu, which provides a vast availability of skilled and experienced workforce. Also, in the area, they have well-established pipelines and also industrial infrastructure, together with strong regulatory and also government support, especially for the oil and gas sector. However, the weakness is high operational and maintenance costs, also the vulnerability to coastal weather and also monsoon seasons, and the location, which is a very long distance from major urban and industrial centers, and also environmental and compliance and monitoring requirements. On the opportunity side, there is a chance of adoption of data-driven and Industry 4.0 optimization techniques, and also expansion into regional and export markets. The plan also aligns with the national energy transition initiatives, and also the potential for collaboration with universities and also research institutions. However, for the threat, there is an increasing strict environmental and also emissions regulations. At the same time, there is also a volatility in global natural gas prices and competition from regional petrochemical companies. There are also risks, especially from extreme weather and natural disasters. Next is the study of capacity management. In order to quantify the operational performance, we have analyzed the capacity metrics. We analyzed the utilization and efficiency of the plant with the actual production of 132 mmscf per month against the design capacity, which is 160. The utilization rate of the plant stands at around 82.5%, with the efficiency of around 91.03%, which is pretty high compared to the effective capacity. This proves that the plant has a pretty strong performance, although there is still a small gap to bridge toward the maximum effective potential. Next is the break-even analysis, which is one of the core objectives of the study. The total fixed costs, including utilities, equipment, and equipment leasing, is around 297,000 ringgit Malaysia per month. By calculating the weighted average contribution margin across the three main products, which are natural gas, LPG, and condensate, we have determined the total weighted contribution of 1.34. This analysis somehow confirmed that the current production level is well above mm, the benchmark required to cover both fixed and variable costs. Discussion. For our discussion, we highlight several key insights. The first one is that the plant operates at a pretty high utilization level, which is 82.5%, and also strong efficiency around 91.0203%, with the gaps are likely due to process bottlenecks rather than in the infrastructure. For the break-even analysis, it confirms that current production uh, it exceeds the minimum required phase level, which ensures financial sustainability. And for the forecast comparison, it demonstrates that exponential smoothing provides better responsiveness compared to moving average. For the SWOT analysis, it has been highlighted that operational strengths and opportunities somehow outweigh weaknesses, but environmental regulations and market volatility remain key risks. In conclusion, the gas processing plant overall operates pretty efficiently and profitably under current conditions. Capacity limitations can be improved through bottleneck management and process optimization, but no need for major capital investment. For break-even analysis also confirms the plant's ability to cover fixed and variable costs, and exponential smoothing is identified as the most suitable forecasting technique. We suggest that strategic improvements and investment in digitalization, optimization, and risk management can further enhance long-term competitiveness and sustainability. To summarize our study, we have validated strong operational performance with 82.5% utilization and 91.03% efficiency. And the break-even analysis also confirmed financial viability. For forecasting, we have identified exponential smoothing as the most reliable method. For the SWOT analysis, it has highlighted that the plan has strong strategic positioning with opportunities, especially in data-driven optimization. For overall results, it supports sustainable operations and also continuous improvement without major capital investment. Thank you. That is all for our presentation.